Good morning. I think it's too loud here. And adjust the volume. So let's settle down, please. My name is Samir Siddiqui. I'm one of the team members of the Shardus project. And on behalf of the team, I'd like to welcome you all on this beautiful Saturday morning. We have a really packed, very informative session today. So how many of you heard of blockchain or maybe Bitcoin? I'm sure, can you show of hands there? All right, so you all know. So by the end of this session, I think you'll all walk out from here what Shardus is all about. Why is it, what we're doing, etc. And we'll have an agenda over here. All right. So what we have today is we're going to do we're going to go into the project background. That's where we're going to spend most of our time today, and that's where we have a lot of information packed. And the speaker is amazing. He has lots of experience. I'll come back and talk about that a little bit later. Then we have a demo, which is going to show us how the consensus algorithm has been implemented. One of the complex modules, one of the complex algorithms that got implemented by the Shardus team. So we'll talk about that. It's a demo we're going to do from our dev team. But first, let's look at this. We'll present to you an introductory video of the Shardus project itself and see what it is all about. So please.
So my name is Omar Syed, and I'm one of the team members on the Shardus project. And my background is in computer science. I've worked for various different large organizations and also small startups. I sort of kind of accidentally got into the distributed systems area when I was working at NASA. Learned quickly how to, scale up web services and things like that. And I used that to help other internet startups with scaling up their back-end services. 2009, when Satoshi released the Bitcoin software, at first, people didn't really quite realize the deeper potential of what he had released, solving a very difficult problem that hadn't been solved before. This breakthrough, what it allows you to do is be able to have multiple parties being able to interact with each other over that same database. And so that's pretty big. If we can still maintain that capability of Bitcoin while increasing the scalability and reducing the energy consumption, then that's kind of like the holy grail. In distributed systems that I've built in all these years, the key technology used to do that kind of scaling is called sharding. And you have different groups of nodes process different transactions or process different data, and that way you get parallelism. So what we're trying to do is build that scalability at the core level, right? So that's usually referred to as like on-chain scaling. We're designing our system to scale as more nodes are added to the system. That should allow us to be able to get to a point where we have distributed systems that can scale linearly, meaning as more nodes are added to those systems, the transactions per second goes up. So we now are looking at transactions per second per node rather than a fixed transactions per second. So once we have that technology, then it's a matter of building applications on top of that. And so the easiest application to build is just a payment network. We refer to that payment network and coin as Liberdis. Whenever you're trying to build a new technology, it's a tough problem, and you're going to need a lot of smart people to be able to work on that problem. And a typical approach that a lot of other projects are taking is that they'll create what's called an ERC20 token, and then they'll, sell that token to raise funds. So we are not doing any kind of sale of our token to the direct public or to investors or anything like that. We are using our own tokens to give to the developers for contributing code and for doing bounties, and other things that help the project. Shardus is building the foundational technology for global scale applications.
She understood that. Although she's Omar's daughter, I think she has that built in her genes. I think she's gonna know Bitcoins right from the day one. Anyway, so hopefully you liked the video. That was just a small, high-level, very high-level intro to Shardus. Now the next what we have is, I'm going to introduce you to the speaker who is the brains behind the project. I've known Omar for over 20 years. I've learned quite a bit from him. His background is, ever since I've known him, he has this entrepreneurial spirit in him. He's never satisfied with anything that he builds. He always wants to build something more, bigger, better. So keeping that, it makes sense why he's doing what he's doing with this. So I've heard of, I remember him talking to me about the blockchain technology in 2008, 9, and he was telling me how it's going to change the world. And I'm like, I don't understand this. I don't get it. So he kept pushing on me, and he's like, no, this is, you'll see it. And then I stepped back and I thought about this, and even 1990s when I first knew him, started to meet him, and I met him, and then he was talking to me about the technologies. He tell me about these applications that are going to come, and then how it's going to change how we operate as the world. And the analogy he used was, he said that how roads connected the cities and the states, the internet connected the world. When they're connected, then the world is not connected, so the applications, the demand, the requirements is going to change as well. So now as I learned more and more about the technology and I started to see the applications, I started to see how far of a visionary he is. So without further ado, I'm going to introduce this. We're going to learn a lot from him. So without further ado, I'm going to introduce, call Omar to give his presentation. Omar, please.
Thank you very much for that intro, Sumit. My voice is not that powerful like Samir's, so I definitely need a mic. Okay, well, thanks everybody for coming out. I think next time we're going to make this event more like in the afternoon so that people have time to wake up and come out. Might be a little too early to do it at 10. But anyways, thanks for coming out. And today you're going to learn a lot about what the Shardus project is and how we got here and where we're planning to go with it. So one of the common questions that I get asked, actually two of the most common questions that I get asked is like, why will Shardus succeed? There's so many other projects out there doing this blockchain technology stuff, and what makes it different, and so forth. So, the thing is that after Satoshi put out Bitcoin and started this revolution, at first, back in like 2010 and 2011, people were just trying to create more coins with it, and nobody really even picked up on that blockchain stuff until actually like 2014 and 2015. And once we kind of started to understand more deeply what it is that's going on here, then, it became apparent that, hey, there's a lot of things that can be done with this. And so I think that we are very, very early on in the evolution of this technology, and we definitely need a lot of projects to be experimenting and evolving and trying to push the envelope of what can be done with it.
in a way, it's kind of like, when the Apple IIe came out. There's a lot of demand for applications on it, but the processing wasn't that powerful. That's exactly what's happening right now. We have, blockchains that are running at, 10, 20,000 kind of transactions per second. And the appetite for building applications on them is so great that even without these things working very well, like all these projects are exploding and trying to get things going on it. And we definitely need to boost the underlying capabilities of that technology so that we can do better applications and more global applications. I mean, the minute you try to run a game or something on Ethereum, it bogs down the network and affects other people. It's not almost like a shared computer, right? So there's a lot of room to expand and experiment and grow. And different projects are going to try out different features, and every time you build a project, you always have to, have trade-offs, right? Like you pick certain things and it's going to affect other things. You can't have everything. This is a huge engineering problem. So as we move forward, I think you're going to see that this technology is just going to keep getting faster and better, and there definitely needs to be a lot of projects out there experimenting. Now, what makes Shardus different is the set of features and trade-offs that we are picking over other projects is really what it boils down to. So what is, one of the main things that differentiates Shardus from a lot of the other projects is that we are using sharding at the core level. So sharding is a technology that originates in the database space and has been used for decades and decades. But we definitely need to apply it to the blockchain space. And we're doing that at the core level. And another aspect is that we're blockless. So I personally think that we got off on the wrong foot by putting all of the transactions in a block and then just processing them block at a time. When you do that, you've already made some trade-offs. For example, there's applications where we don't want everything packed in a block and consensus done on it at the block level. You really want the consensus done per transaction. And basically, if you think about it, the analogy is kind of like taking a bus versus taking a car. When the consensus algorithm is really expensive, you don't want to sit there doing consensus on every transaction. You'd rather pack them all together and sort of do a group consensus on this block of transactions. But when your consensus algorithm is more efficient, then you can just do consensus for each transaction individually. So as we figure out how to do consensus more efficiently, I think you'll see more and more projects shifting over to becoming blockless. We're sort of starting to see that with some of the projects doing like DAGs already, but we're not even a DAG, we're just completely blockless. Each transaction is processed individually. We can go through the list of other things, but that would bore you guys, and so what I recommend is just really go out and read the Shardus white paper. We try to make it so that it is not like so technically hard to understand. Anybody should be able to read that paper and get a lot from it about what we're planning to do. But aside from these kind of aspects, there's other questions that whenever you approach any project that you really should ask, which is, who's behind the project, why are they doing it, what's the motivation for doing this project, what's the long-term vision, and can they really deliver what they're promising, right? So those are kind of things I think are actually kind of more important than any kind of promises that you make about what's going to, what we're going to deliver. Because if you don't deliver, then none of that counts, right? So you really got to look at the broader picture. So I want to start off by telling you a little bit about myself and why I got into this. So I grew up in Cleveland, Ohio, and our family lived close to one of the NASA centers over there. And as a child, I often visited this NASA center. And at the front of the center, there was this big sign that says NASA for the benefit of all mankind. They changed it now. They took out the mankind part of it, politically correct, I guess. But anyways, I remember as a kid looking at that and thinking, oh my God, wow, this is like, I was just inspired when I read that, and I thought, but this is the kind of place I want to work for. And unfortunately, after I graduated from college, I was fortunate enough to get hired there, and I worked there for 10 years, and met a lot of amazingly bright people. One of them is Don Brown. Like, you'll never hear about him, but he's a genius. Like, but buried in these kind of places, there's a lot of really smart people. But I was inspired by that kind of motto, and when I started my company in I think 1996 to help do consulting for internet startups and so forth, I wanted a motto for my company, and so my motto was working to make the world a better place for everyone. And so that's kind of been my philosophy and drive of how I approach things and why I'm doing things. And I think it's important to do that. Even Google has that motto of do no evil kind of thing. So when you set a motto for what you're doing, it kind of like provides this high level principle and guidance for you to work towards. But that's kind of my motto. And so why are we building Shardus, and how does that all tie into this? 10 years ago, if you'd asked me or said that I would be working on this kind of technologies, I would have never believed you. But it all kind of started back in like 2008. So Ron Paul was running for president at that time, and I usually don't follow presidential elections, but somebody told me, hey, listen to Ron Paul, the guy's amazing. So I started listening to his lectures, and I was really impressed. And one of the things that Ron Paul often talked about is that we need to go back to using sound money. And at the time, I didn't even know what sound money was. So I was like, what was he talking about? And so I had to do a lot of research to find out what he's talking about. So in doing that, I found out that our money actually used to be backed by gold, and you could actually go and trade your dollars for gold. And this went on for quite a while, and then in 1971, Nixon kind of just announced that, hey, we're not going to do that anymore. You can't convert your money back to gold, and at that point, our money just was based on faith. So as I kept researching and finding all these interesting things about money that I didn't know about, because I think most people don't sit there researching money. It's just something that you use, and that's the way I was. I learned a lot of new things, and studied the history of money and saw how it went through different stages, going from a commodity to gold and shells, and eventually to paper money, and now we have electronic money. It was a very eye-opening experience for me. And when I looked at that, I noticed that essentially what's happening is that people want their money to be more and more convenient. And as we move towards more convenience, we end up becoming more centralized. So, commodity money was very decentralized. But then once you got into coins and then to paper money, and then eventually now to electronic money, we're even, giving up some of our privacy in exchange for that convenience. So we've been going on this trajectory of giving up convenience or gaining convenience in exchange for our money becoming more and more centralized. And so going back to what Ron Paul said, it made a lot of sense to me that, wow, money should really be backed by something. And I started thinking about, well, what should we back money with? Should it be gold? Should it be, energy, oil, land? What would you really back the money with? And it's, no matter what you try to back it with, it's, you're going to have to put some physical thing away and make sure that it can be, exchanged back for it and so forth. And after a while, I realized that, money is just this made up fictitious thing. And it's just a way for us to keep track of who's done what for somebody else. And if you don't have humans, you don't even need money. So it kind of makes sense that really you could back money with human time. And if you did that, that would probably be the ultimate way to do it, but how would you do it? And after a lot of thinking, I came up with some ideas, and I wrote this paper called Sound Money Without Commodities. If you Google that title, you'll find that paper and read it if you want. But essentially, I realized that it's possible to have a rule-based monetary system that is resistant to inflation and deflation, and actually kind of backed by human time. And the system is pretty simple. There's only 2 rules to it. So every day you could have each individual in your economy receiving some fixed amount of currency or token or whatever you want to call it. Example, let's say you give out 10 tokens per day to each individual, and you can think of this as like universal basic income. And it's new money, it's not coming from somewhere else. This is like newly minted, just like how we newly mint Bitcoin or any other crypto coin. But if you kept on doing this, then you're going to have inflation. So you need another rule, which says that about 1% of a percent per day is deducted from your account. And that amounts to about 3.5% per year. And that amount that's removed doesn't go anywhere else to hurt to anybody else, it's just destroyed. And so at the time I didn't know, but there's a word for that when it's applied to money, it's called demortgage. So you basically have what's called demortgage. So you have like a 1% of a percent per day demortgage rate. And that prevents inflation, and the system actually comes to equilibrium. And so the equation is essentially like your new balance is your old balance plus some daily income amount minus your balance times the demortgage rate. And so you're adding some and you're subtracting some, and eventually what you're adding and subtracting will become equal. And it'll reach some equilibrium. And for this example here, you would end up with about 100,000 coins in your account if you didn't touch that account at all. And from that, you could figure out that, well, the supply of money is going to be proportional to the number of people in your economy. So if more people join your economy, well, the money supply is going to increase. And if people leave your economy, the money supply will automatically decrease, and you don't need some privileged entity to try to decide how much money should be in circulation. And so, if you had an account and you start from 0 over time, and this would be like 20 years, you would get to around 50,000 tokens in your account, and eventually you'd asymptotically approach, 100,000. And if you had more money than 100,000 in your account, due to that demortgage rate, it would decay if you didn't do anything with that account. So it reaches some equilibrium number. And then I started thinking about, well, this is cool, but how would I actually implement something like this? And I thought, well, maybe we could use something like the domain name system, where they have, a international body that issues licenses so that companies can become domain registrars. And in the same way, you could have some regulatory organization that sets up money registrars. And these money registrars are not like banks at all. They're just companies that provide you an account, and you go and register with your local money registrar and set up an account there, and every day your account would receive, like, say, 10 tokens, and there would be a small demurrage on that account as well. And the system would work based on that, but you'd have situations where somebody would want to register with multiple registrars and so forth, and so you need some sort of a shared database that all these registrars could compare against to make sure that somebody isn't creating multiple accounts. But then what would you do about some rogue registrar that just creates fake accounts and earns money that way, right? Like Wells Fargo was creating all those fake accounts. There was nobody behind them, but they were generating money. But so anyways, I was thinking about, oh, this is not an easy problem actually to solve. And so I searched on the internet for DigiCash. DigiCash used to be a project back in the early 1990s where they were trying to create some sort of a digital money system. And when I searched for that, I came across Bitcoin and worked my way to the Bitcoin white paper and read that, and I was just like blown away by what it was saying. And just because I had recently been studying money and looking at it, it meant a lot more to me than probably a lot of people that first time come across this. And here's this guy talking about, oh wow, we can have this purely electronic version of cash that we can send around the world. And I was like, well, this is amazing. And so the first thing I did was try to mine Bitcoin, and that didn't go over very well. At the time, compared to now, it was a lot easier to mine it, but still at the time it seemed hard. And then I tried to buy Bitcoin, and that didn't go over very well. I eventually ended up buying Bitcoin, but one of the things that I realized from reading Satoshi's paper was that what he's actually trying to do is give us even more convenience by, low transaction fees and fast transactions and decentralization, and just basically undoing what had happened over all these years as money evolved. Ideally, this is where you would want money to be. You want it to be very convenient, and you want it to be decentralized. And as money evolved, we made it more and more centralized, but Bitcoin was going to wipe out all of that in one shot and make it more convenient. It was like, whoa, this is amazing, right? And so I really had to get my hands on some Bitcoin, and eventually I found that I could sell some Arima sets for Bitcoin. And Arima is a game that I had made. It's kind of like a board game, and there's a sort of a cult following on the internet for Arima, and some of the guys that were playing Arima had been mining Bitcoin since like 2009 9 and had like lots of Bitcoin sitting around, and so I was able to sell some Remo sets for Bitcoin. But you know, at the time, when I actually downloaded the Bitcoin client and tried to use Bitcoin, it was not a very good user experience. And the very first thing that I thought of was like, man, we have to we want a lot of people to use this, but this just is not going to fly the way it is right now. We've got to change the architecture of how this thing works. And so, you know, you have your Bitcoin core nodes that provide the network, but I thought, well, we should really have another gateway peer-to-peer network on top of that, where these nodes are not participating in the consensus, but they're still receiving and validating all the blocks. And then you could have these light clients that could talk to these gateway nodes, and these gateway nodes could actually create like a distributed hash table and be able to hold mappings like, you know, email address to your Bitcoin address and other kinds of data, like, you know, what any notes that you wanted to make with your transactions and all kinds of things like that. So I wrote up this paper about the Bitcoin gateway, and you know, it's essentially intended to be sort of like a vault to hold your private keys encrypted and on this Bitcoin gateway peer-to-peer network, and it could provide a much better user experience where people could actually use their email address or username or something like that to specify, you know, how they want to get their Bitcoins received. So I wrote this in 2011. I even like posted it in the Bitcoin developer group on bitcointalk.org and so forth, but I think it was a little bit too early. People didn't really catch on to that, but now we're starting to see some projects, you know, doing things like that. You know, Dash is working on providing this layer, and there's a few other coins that are trying to make the whole user experience more friendly. So, you know, so at that time, you know, I could see there's issues with Bitcoin. You know, it's not very user friendly. You have to download this big chain blocks before you could actually, you know, send out a transaction. Addresses are very cryptic, and the price was going to be volatile just because of the nature. It's not Bitcoin's fault. I mean, just, you know, whenever you have any kind of a limited supply resource, it's going to have a lot of volatility. But there was also a lot of power consumption going on in order to do the consensus, and it definitely was not scalable. I mean, because the way I looked at it, I was like, well, if we add more nodes to Bitcoin, what's going to happen? It's like, no, that's what's going to happen. It's just going to have to transfer more transactions to more nodes. It's not going to get any faster. That's not how we design systems. So, you know, adding more nodes doesn't help. So it's not scalable. You know, the word scalable means that as you add more resources, the system should increase its throughput or capacity, and you shouldn't use the word scalable unless your system can do that. Right now we have like all these systems saying, oh, this network is more scalable than that network and so forth, but they're all, you know, have their fixed speeds. They're using the word scalable where really you just should be using the word faster. So how could we do more efficient consensus? So that I started thinking about that, and so this actually happens in nature all the time. And there's a phenomenon known as genetic drift, where what happens is if you have a population of specimen and half of them, say, have one characteristic and half have the other characteristic, over many generations, the population will converge and all the specimens will have the same characteristic. So in this case, you know, if you had like 50% of your chickens were white and 50% of your chickens were black, and if you cross 2 white chickens, you get a white chicken. If you cross 2 black chickens, you get a black chicken. And if you cross a white and a black, it could be 50-50% chance either way. So if you kept, you know, producing generations that way, one or the other color is going to win out. And I knew about this because I had done my master's back in like 1995, where we were using genetic algorithms to evolve neural networks. And I was actually trying to fight convergence because I didn't want all my specimens to become the same thing. You know, so we're actually like introducing mutation into this population to keep it from converging. And you know, I knew that there's a certain rate at which your population will converge, and it depends on your population size. So if you only had, like, say, 10 specimens, after about 10 generations, only about 10% of the population would be the minority color, right? So most of it, 90% of it, would have converged to one of the colors. And as you go down to about like 40 generations, you've pretty much lost it all. But if you have like more specimens in your population, the convergence takes longer. But you could actually normalize this, and it turns out that for any given population size, it only takes about 6 times that population size number of generations to lose all your diversity. So I wanted to see if I could apply that to you know, doing consensus, because you know, I knew that happened. So all we need to do is have the nodes like query other nodes and ask like what their color is, and then based on what most of the other nodes are saying, you just switch over to that color, and then slowly over, you know, a few iterations of this, the population would converge to the same color. And color in our case would actually mean a transaction that's, you know, saying do one thing versus a transaction saying to do another thing. So I wonder if you could maybe hit the clear button on that and then set one of the nodes to a color, and then click the sim button. So there's a node, and you know, transactions come into the network and they're passing it around. And this is an easy case because you don't have any conflicting transactions. All the nodes will just pass that transaction around, and eventually they'll converge to the same thing. And let's see, it's still ticking. So it took about 200 messages, and in about 2.2 seconds, it would converge. So if you hit clear again, and then this time set one node to like red and another node to blue, and then hit sim again. And now you've got conflicting transactions going through your network, and the nodes are going to query other nodes and find out like what they're saying, and then choose one of the colors, and eventually the network will converge to one of the colors. So it's not that difficult. So it doesn't take a lot of work to do this, or I mean, you don't have to. So why it takes a lot of effort in Bitcoin is because you're funneling all your transactions through one node, and the one node gets to say which transactions are going to be applied and in which order. And how do you choose which node gets to say that, right? I mean, that's kind of a privileged position to be in. So all the nodes are competing, and they compete by trying to solve a mathematical problem in order to prove to everybody else that they've solved this problem, and therefore what they said should be accepted by the network. But you don't really need that much energy to do something like this. So the other thing is, can we make the network scalable? So that, in all the years that I've worked at various companies, building back-end systems to help them scale up and meet the demand for their mission-critical systems, we've always used sharding. And in this scenario, you could have these networks sharded so that you have groups of nodes and you've got different shards. And you could do the consensus within a shard, but then you need to have some cross-shard communication so that this shard could prove to that shard that the transaction was accepted here. So for example, if you're going to be moving some points from account A to account B, well, first you got to go to account A and make sure that there's money in the account, right? So the transaction might land over here, and these nodes would do consensus and validate that, yeah, this transaction can be accepted, but then they need to send some sort of a receipt to the nodes over here so that these nodes know that it was already accepted, and now they can increment the value in account B. So we need sharding, but the difficult part is that proving to other shards what happened in another shard and sending that across to each other. But that's an engineering problem, right? And if we could build something that could actually be efficient and more scalable, then we could have like phenomenal throughput of our system, and we could actually get into like billions of daily active users. I mean, if you really think about it, long term, that's what we should be planning for. I mean, we're right now you won't hear any project talking about more than like 1 million daily active users. That's huge. I mean, we don't do that right now. But if you really want this technology, if you really want to build like a coin that the whole world can use, you really should be thinking about billions of daily active users. And at those kind of numbers, you're going to have easily millions of transactions per second. And unless you have that as your goal of what you're trying to build for, you're just going to keep building these interim solutions and then have to keep upgrading those. So we're taking a longer approach. We're not going to be just building something really fast and putting it out there. I mean, it's harder to put something out there and then upgrade it later, especially when people are actually using it, And that's what's happening like with Ethereum. Ethereum has plans to do sharding and so forth, but it's not going to be easy, I mean, because you've got billions of dollars of people's money on that network, and you can't screw up. I mean, like you saw what happened recently with Bitcoin, where they did some upgrade. Unfortunately, somebody realized that there was a bug in it, and the guy was good enough to tell the core developers, and they got things fixed up before something drastic happened. But so we want to make sure we build something right the first time and then launch it. So what we want to build, so this goes back to what I talked about earlier, the sound money without commodities. We'd like to build some sort of electronic global coin that really billions of users could use. And if you have something like universal basic income, yeah, why wouldn't people sign up for using that coin, right? And so that's one of the things that we're shooting for. But in order to do a coin like that, you also have to solve a very difficult problem, which is the problem of decentralized unique identities. And we've thought a lot about that problem as well. And we have a paper on how that can be approached, and it essentially requires using like a web of trust along with principles from game theory, and then using oracles and incentivizing everybody correctly so that somebody can't create duplicate accounts in your system. So, but once you have that kind of system, you can do a lot more with that kind of system. You can have reputation. Right now we use the credit rating systems that these private companies have, but eventually I see that becoming a global thing. So you can have communication networks. So right now we have a lot of companies providing communications, but that should be a public utility. So there's a lot of things that can be built on top of this, and even a lot of other organizations can plug into the system like this if it's a public infrastructure. Because there's so many times when you want only a unique user to sign up on your website, but you can't do that right now. So people use things like Facebook account or Twitter account or something like that to try to make it unique, but those things can be gamed. So those are the kind of applications that you could build if you had this technology. So the big picture is, first we need to build Shardus, and that's going to provide the foundational technology. And then we're going to build the first application using that technology, which will be a payment network and a coin, which we call Liberdis. And so you could kind of think of like Shardus as like the blockchain layer, and then Liberdis is sort of like Bitcoin being like the first application of that technology. And then you could also build something like Ethereum or EOS, where it's a smart contract layer and a virtual machine, but it's built on top of that original Shardus technology. And there can be lots of other projects that fork that technology and use it for lots of other applications, whether it's public utility or enterprises. And then once we have something like the Shard OS system, where you have a virtual machine and smart contracts, then we can actually start building things like global electronic trading coin and Globalville and so forth, and other things can be built on top of that. So that's kind of a big picture of how we see things going. So the roadmap is Q3. We've been testing out our consensus algorithm. Q4, we're going to build a server that is focused on just one shard, and just work on trying to increase our transaction throughput for just the one shard. Then Q1 2019, we're going to build what we call our Shardus Global server, and that will provide for multiple shards, and that's when we start getting into being able to do transactions per second per node, with approximately, say, like 20 nodes per shard. So even if you get like 20 transactions per second per node, then as you increase the number of shards, that number would multiply. So if you have 100 shards, you're looking at 2,000 transactions per second. If you have 1,000 shards, you're at 20,000 transactions per second, and so forth. So that's where we're trying to go with that. But then we're still, at this layer, we're still keeping our transactions kind of simple. And by simple, I mean that the transaction only spends from one account or affects one source account. You could eventually have situations where I need to take money from this account and that account and that account, and then I'm going to send that to 10 other accounts, right? So those are complex transactions. And so in Q2 2019, we're trying to shoot for that. And that, when you're dealing with having to do consensus at multiple different shards and bring that all together, that is going to impact the number of transactions per second that you can get through the network. And so that number will probably go down But as I said, if you scale with more shards, then you'll still be able to get to whatever level that your system needs. In Q3 2019, then we're going to try to shoot for starting to build the Liberdis network. And in Q4, we'll put out the Liberdis testnet, and hopefully Q1 2020 we'll get to our Liberdis mainnet. So we have a long ways to go, and we need a solid team for building this, and we're working towards building up a team. Right now we have 15 developers, 5 advisors, and 1 community relations manager. And we have members on our team who have built scalable mission-critical systems for a lot of big organizations. So the leadership is really good. We have architects on our team that have built really solid systems for these companies. Samir, for example, was on the team that did the Yahoo front page, and they have to handle millions and millions of daily active users. I worked for Zynga, worked at NASA, Yahoo as well. And so this is our current team right now. We have 5 developers here in Dallas area, and then we have about 10 developers helping us around the world as well. And each of those developers was handpicked. So it's not like we just went to some outsourcing company and said, give us a bunch of developers. No, we interviewed each of these guys. We gave them 3 tests, and they all had to pass the test. We went through about 400 people before we picked those 10 developers. So they're all just really smart guys. So we have a pretty solid team. And we're going to be adding more people as well, and bringing in more talent. Now, another question that often comes up is your project open source? Yeah, definitely, it's going to be open source, but that doesn't mean that we have to make our source available right now. It doesn't make sense to do that right now. But once it's completed, it will be open source. Everybody will be able to look at it before they actually start using our code, before it goes live. And the reason why you want to do that is just because there's so many projects out there just using hype and ICOs to fool people and do things. And yeah, we don't want to just put our stuff out there. And also, that there's a lot of companies out there who are big companies. I'm talking IBM and Bank of America patenting stuff. And if you just put it out, they could actually patent it. Because in America now we have first to file. It's not whether you could prove that you actually had developed that technology first. It doesn't matter. If you patented it first, you get the rights to that technology. And so you could get hit reverse, right? You actually build it, but then somebody goes and patents it, and now they tell you to license it from them, right? So it doesn't make sense to just put it out there right away. But once we've got it developed, we're actually going to apply for patents, but we'll use them defensively. We're not going to go after people if they use the technology. In fact, you'll be able to fork our software and use it. But it'll show that the technology that we're building is patentable. And I've built technology at Yahoo and other companies where we've applied for patents, and I'm very familiar with that process. And anyone interested in looking at what we're building, you're welcome to contact us, come to our office, and you can look at our source code, talk to us about what we're building. So we're definitely open in that way. And the other approach that we've taken, which is different than a lot of the other projects out there, is that we're not doing any kind of an ICO. So we're not going to be selling our tokens to any private investors or through an ICO or anything like that. right now that's just kind of become like the easy way to make money. I mean, because you can actually like leverage that, right? You can go to some angel investors and get them on board, and you go to some VCs and you give them all, really good deals on your initial pre-sale, and then you can go to the ICO and say, look, we've got all these people, and then even the ICO, they structure it so that if you get in on it first, you get a discount, and wow, you can take almost anything, and if you set it up in that kind of a structure, you can get people trying to, buy into that just because they know there's somebody else coming in later who's going to pay more for it. And unfortunately, because, SEC isn't getting on the ball and doing something about this, people in the U.S. are being the last people to be able to get in on these, because we have to wait until things get on the exchanges before we can buy them, and the rest of the world is participating, in the ICOs. So U.S. Needs to get on the ball and, think about, how to help our investors really. I mean, the rest of the world is going to pass us up if we don't do that. Also, this approach of what we're doing, where we give our tokens to our developers, is actually sort of setting up a new model for how open source software can be developed in a collaborative way. I mean, in the past, you had what Eric Raymond referred to as the cathedral and the bazaar, where the cathedral is like, some company like Microsoft or IBM or whatever, in-house building this software. And then you have the other extreme, where you have a bunch of guys getting together on GitHub and trying to build this open source software. Why? Because they want to build this, because there's a need for it, and somebody's building it, not because they want to sell it or anything, but just because they want to use it themselves. And so you have those two models of the cathedral and the bazaar, but with tokenization of software development, you can have something actually in between, which I'm referring to sort of like a guild, where it's not like a company completely, and it's not completely like, just a bunch of developers with no coordination. The tokens actually allow you to structure the development and facilitate and provide incentives for people to help you on building that software. So we're going to be seeing this new model of software development emerge, and I think we're one of the first ones to do this. Also, we don't have to waste any time and resources on fundraising, so we can go straight to doing our development, right? So we don't have this 6-month cycle going through talking to, VCs and then going through an ICO cycle and all that. No, I mean, we want to be focused on doing the development, and eventually you'll all realize what we're developing and eventually come to it. And it also provides us with what I refer to as just-in-time capital, because now we don't have any worries of running out of money, because we've got our tokens that we can keep on giving as we need to do more development and bounties. And we also don't have to worry about what to do with all this excess money that we raised up front. Like a lot of projects out there, they'll raise like $100 million. Well, you don't need that. I mean, like, let's see these projects that have like hundreds of millions of dollars, but like maybe 10 developers. God, you don't need that much money. Really. And so now it's like, well, if they don't efficiently use that money, then that capital is being underused, right? So now in this model, you have just-in-time capital. And then also, the efforts are rewarded after completion of the project. Like, our token is worth 0 unless we deliver the software. And So we have a lot of incentive to get this software built. And we're not, given all the reward up front to say, go build it. Because, people could lose their incentive to actually work on the software if they got too much reward at the beginning. So it's better alignment of the incentives overall. So, I hope more projects look at this model. It can work. The only thing is you have to, rather than spending your resources going through the fundraising process, you have to spend your resources on convincing developers that your project is worth working on. So, and developers are, I think if you can convince developers that your project is worth working on, that's more important than convincing some VCs that, the project is better. So what would the Shardus token be used for? So it's right now set up as a ERC20 token, and the project values it at 10 cents per token, and that's the rate that we use to give our developers and for completing bounties. And the nice thing about it is that we were able to get it, like before, if somebody did want to buy the token, like they'd have to go to one of the developers and ask them if they would sell some tokens. But the Bancor network actually allows anybody to be able to set up a token on the Bancor network, and it doesn't have to be the project. So our project never had to do anything with the Bancor network. Our developers were able to set up some contracts on the Bancor network and make the tokens available. And so now anybody in the public can actually go to the Bancor network and buy the tokens that way. So the tokens, long term, they're going to be needed to pay licensing fees for the software. So even though our project is open source, if you remember the early days of open source, it said open source does not mean that it's necessarily free. And like what Richard Stallman says, it's free as in freedom. You have the freedom to look at the code and change the code. It's not necessarily free as in free beer or pizza. So you will have to license our software, but the licensing is done in such a way that even that is decentralized. You don't have to come and talk to somebody at a company to license the software. So for public projects, we ask that they give at least 1% of their initial coins to the Shardus token holders. So in a way, you can kind of think of this as like what's happening with EOS and what's happening with all the airdrops in Ethereum and so forth. And it helps the project as well because it helps them gain a community of users, from all the users that are holding the Shardus token. And then for enterprise use, they would be like using our software, say, behind firewalls or in a private setting. Our ERC20 contract actually has a function on there where you can send tokens to that function to burn the tokens and receive a license token, and it would have your company name or whatever in that token, so that you could prove that, hey, we've got a license to this technology. So that's one of the cool things about distributed ledgers, and anybody can see that somebody has gotten a license. Like previously, when one company got a license from another company, only those two companies knew about it. But now this is on the blockchain, so when you get, when somebody gets a license, everybody else can also see that they got a license. And so even though it's based on the honor system, the companies will want to actually get a license because it can be seen whether they have a license or not. And so when they burn the tokens, it also reduces the Shardus token supply, and that benefits everybody. And when Liberdis gets launched, all the Shardus token holders will be able to claim one-to-one a Liberdis coin for every Shardus token that they have. And this is not a conversion because you don't lose your Shardus tokens. This is just a claim. So you're able to use your Shardus tokens to be able to come to the Liberdis network and prove that you have those and claim coins on the Liberdis network while still continuing to hold your Shardus tokens. The token supply, right now there's only about 5.3 million tokens in circulation because we're only giving them out as we need to for development of the project. And we publish a monthly distribution report. It's in the wiki section of the Shardus.com site, so at any time you can go and look at that and know exactly how many tokens are in circulation. You can also validate that by checking it on the Ethereum network. And we're distributing them based on the 10-cent per token value, and so that kind of puts our market cap right now at just $500,000. By the time we launch, we complete Shardus, we complete Liberdis, and launch the Liberdis main network, we expect that there would probably be about 60 million Shardus tokens in circulation. So that, even within that, only about 50 million would be used for development, and then 10 million of that we're going to use to help build awareness of the project. So there's not going to be any more distribution of the Shardus token once we've released the Liberdis network. And any further development of Shardus or Liberdis is going to be supported by a maintenance fund that's built into the Liberdis network. So that's very similar to like what Dash is doing. If anybody's familiar with how Dash has a maintenance fund, they have that whole masternode voting system and so forth. So Liberdis is going to have those kind of features built into it as well. So here's an actual monthly distribution report from our website. So we sort of have a estimated of what we're going to be hitting, and this goes on further for all the quarters. And then this is our actual tokens in circulation. So we're actually like just a little bit over half of what we expected to be at. So we're like under budget. And so the current status is that we've developed and validated our consensus algorithm, and that was our main goal for this quarter. We've tested it on the AWS using the global network. And right now it's single shard. We're using 25 nodes per shard. And on a global network, we can get 100 transactions per second. But one of the key things to remember is that we're using actual digital signatures for doing our consensus as opposed to using what's referred to as MAC signatures, which are a lot cheaper. So digital signatures allow you the ability to be able to prove to another shard that the first shard actually agreed on something. So there's a lot of projects out there that can hit way higher speeds because they're using MAC signatures, but you can't use a MAC signature to prove to somebody else that consensus was achieved in the first shard. So eventually, if they want to do multiple shards and scale up, they're going to have to do digital signatures, and they'll take the hit. But we've already, designed for that. And if we just use like a single data center, we're actually getting like 700 transactions per second. So like for a private or an enterprise network, yeah, you could actually get way higher numbers than that. And we've also developed a mobile app, and if you guys have an Android phone, you can download the mobile app. You'll just go to the Play Store and search for Shardus, and then you'll be able to interact with the network. And we're going to give you a demo here in a little bit, but while the demo is going on, you can actually interact with the network while it's being stress tested. And then Apple won't allow us to put a demo app on their store. So for Apple, we've developed a web-based client, so you can just use Safari to be able to access it from Apple. And the web wallet could also be used from a desktop computer as well. So that's the current status. And next, well, there's actually more to it. We've also been doing a lot of investigating into, what core technologies we want to use. There's a lot of network communication that happens between these nodes, and TCP/IP necessarily is not the best way to do it. And so we've been investigating a protocol that Google has come up with called Quake, and they're actually using it in their browser. A lot of people don't even know about this, but we're planning to use that. It's built on UDP. So it actually, we found in our network benchmarks that it could be 2 to 3 times faster to send a message across the network using Quake versus TCP/IP. Also, we're investigating some, quantum-resistant digital signatures, just for the long term. We believe that, the way we should design this system is that currently we should be using ECC for digital signatures, but designed so that the system can be upgraded in the future to use post-quantum cryptography. And we've also rebranded the project. Used to be called Unblock Ledger, and now we've rebranded it to Shardus. And we've also moved our repo from GitHub to GitLab. If you're a developer, you probably know why, but won't get into that. But that's another thing that we did. Okay, and so next quarter, as I mentioned earlier, we're planning to build our enterprise server. So that server will actually provide the features of, doing network discovery, joining, syncing, resyncing, and all these other things that you need to have a full-blown server running. And also we're going to design the server architecture in a very modular way so that the consensus algorithm is just one component of that architecture, and you can just plug in a different consensus algorithm into it. Also, the application layer will be very clear and separated so that you can easily change this application from being a payment network to something like a communication network or any other project. And we'll be updating our mobile wallet as well as our web wallet. And we also will be building a web-based explorer so that you can look into the network and see what's going on, see the transactions coming in, see what the state of the network is, and so forth. And we're also going to be investigating using Schnorr signatures. So Schnorr signatures will help us out a lot because they allow you to pack a whole bunch of signature verifications into just one signature verifications. And verifying signatures is usually about 3 times more expensive than signing. So that's going to help improve our transactions per second. And we're also going to be conducting a social media bounty program to allow people to join our social media channels, learn a little bit about the project, and receive some bounties. So yeah, definitely, join us if you're talented developers. We're always looking to get more developers on the team. You know, if you believe in the vision of what our project is doing and you want to change the world and, you know, make the world a better place for everyone, you know, the world is getting that way because of technology more than anything else, you know. I mean, we live now better than what the kings lived in their times, and it's really due to the technology getting better, and everybody is prospering because of that. And so, you know, improving our technology is the key to making a better world. And you know, you can complete bounties. We have some bounties listed on our bounty section at the Shardus website. And you know, feel free to suggest other bounties to us. You know, contact us and say, hey, I can do this for your project. You know, and you're welcome to connect and help us out and earn Shardus tokens that way. So with that, we're gonna go switch over to Amir and Derek, who are gonna do a quick demonstration of actually showing you our network running on AWS.
Yeah. All right. Hey everybody, my name's Amir. So you've heard a lot about how consensus algorithm is going to work and how what we plan to do to make it scalable and whatnot. Now it's time for something fun. Let's actually try it out. Okay, so Omar mentioned that we have a mobile wallet app for Android. If you have an iPhone, you can use the web-based wallet. So if you all want, take out your phones, go to the Play Store and download the Shardus mobile wallet app. If you have an iPhone, go to w.shardus.com. All right. So I already have it downloaded just for demonstration purposes. Let's do something real quick. So we've made a working version of this Shardus consensus algorithm. Like the graph that was here before, we've actually implemented a server in Node.js that does whatever that was doing. And on top of that, we've built a demo application, kind of like a wallet, that you can use to inject transactions and watch them like actually happen. We have about 25 nodes running right now, and they're on AWS instances, and they'll take care of your transactions. It's usable. So, Derek, you want to go ahead and move to the receive page? I'm not sure if you all can see this, but I have about 112 coins on my phone right now that I've already created. You guys can create coins too if you go to the create page or the second tab from the top. It says create tokens. You put in some number and make them. Don't give yourself like 9 million coins or something. But okay. So here we have the receive page. Everyone's wallet has this as well. I'm going to send. Let's see here. Let me send 13 tokens to the wallet that's displayed on the screen here. I'm going to go to this transfer page. I'm going to put in the number 13. Hit the QR scan button on the side.
So what's the current balance?
Current balance is 1,100, right? So that should go up to 113 after I do this. Scan this QR code. All right, got it. Hit the send button. It says alert transferring. Now if you go to the transactions page here, in a couple of seconds, hopefully you'll see the number 13 pop up. This is really nerve-wracking for me.
What's the receive there?
There you go. You got 13 tokens that transferred from my wallet over to the wallet that's running on that computer over there. And this is all taken care of in a completely decentralized, secure way by like 25 servers running on AWS, running our server built in Node.js. So yeah, if you guys have gotten the app on your phone, you can try like transferring tokens to one another. Scan your guys' QR codes, go ahead and use it. Let's see what happens. All right. So token transfers are working. That's a cool thing, right? You can send transactions to one another. They'll go through as we just showed up here. But is that really useful when the network is really, really stressed out? Like, I'm sure you guys, I'm not sure if you've heard of CryptoKitties. When that came out for a while, Ethereum was like bogged down, nothing was going through. So we're gonna try stressing these servers and then still see if transactions go through. So Derek, you wanna go ahead and start stress testing this thing? We'll try putting about 100 transactions per second through it. Randomly created accounts, randomly created transactions, and just sending transfers between them 100 per second. And we'll sustain this for at least 5 minutes. And while that's going on, you all can go ahead and transfer points to the wallet up here if you'd like to each other. What's that? Create tokens once. Gotcha.
No, let me make it twice.
I tried to create multiple times and that's where it's
So, just to add to what was built here by the dev team here, is basically essentially the consensus algorithm that we have seen, by the simulation that Umar just showed you all. If you could really simplify it, there's a lot of things that are happening behind the scenes. When you create tokens, there's consensus that are happening. When you create the tokens, there's a lot of consensus that are happening. Plus, when you're transferring the tokens, there's consensus happening behind the scenes. So for the end user, this is all hidden technology. Everything is hidden. The complexity is hidden.
Yep.
Underneath it, the consensus is doing all the legwork. So if you were to summarize everything that you've heard, it's basically saying, okay, the technology that is being built through Shardus can be used to build global applications. Consensus, servers, everything else, using that. So I think Derek just now kicked off a test, and you can see that it's sustaining the stress test.
Yeah, you see the network traffic is spiking right now because we're sending about 100 transactions per second through this thing. We're gonna be sustaining that for a while. And if you guys try any transactions, they should go through. Derek, you wanna go back to the wall and see if we can do this on stage?
Anybody not able to create tokens, give it to yourselves.
No, it's not adding more. Like if he sent me some, it still says big amount. It doesn't add it up. It says it came with the total balance that it say on there.
Yeah, it's probably something with the refreshing of the balance page. This is, you guys gotta understand, this is still like super, like not even alpha software.
Also the number
Yeah,
the
network.
balance works.
Yeah, it probably takes a while for it to go through sometimes. But okay, so while the stress test is running, Derek, go ahead and go to the receipt page. We'll go ahead and try sending 7 tokens this time. Do it.
Yeah, I haven't gotten yours yet.
All right, so I'm going to show us while the network is loaded right now, the transaction processing 100 transactions per second. Can you show us how to receive the tokens right now?
Yeah. All right. So
Yeah, I just got it. Oh, my balance is 0.
So if you look at the balance page right now, it got set to 0. Upon starting the stress test, we reset the nodes. So that's why all the balance went to 0.
Oh, that's so fun. We should
Yeah.
be here.
We got 25 nodes, and we have to do everything on them. All right, so balance got reset. It's still going on. The stress test is still going on. I'm going to try sending nodes, tokens from my phone over to this wallet right now.
So someone else can send you the tokens. Let someone else send the
I think
coin.
these guys are.
Are you trying
Can
to
you
send
guys,
that?
can you all get the QR code from over there?
Yeah.
You can come on up if you want to.
Yeah. Good job. Others can send too, so see if you can. Let's see who gave us the most tokens.
Who's the most generous? So when you hit the QR code, not that right there.
댓글로
There you go.
So this is all running on Node right now. That's cool.
Yeah, this is all running live. You're interacting with live events.
All right.
So now we're going to the balance phase. If y'all had sent a transaction or anything,
Let's track them. Who gave 12? Okay. Who gave 4? Who gave 9? All right. So we were able to grab those tokens, and this is all happening behind the scenes with through consensus.
yeah, this is going on. While the nodes are still being stressed at 100
We got one more who gave
transactions.
1.
Come on, line.
Yeah, so your transactions went through, as you can see, in a couple of seconds, right?
And as there was stressing the system.
Exactly, as the system was being stressed. And now, so we're running 25 nodes right now. This worked with 25 nodes running on AWS instances in like 5 different regions. We have like one in Korea, like one in all over the world, all over wherever AWS lets you make nodes, we make them. Now, it took maybe about 15 to 20 seconds for your transaction to go through while it was being stressed at 100 transactions per second, right? What sharding means and what this whole thing is about is that it'll still take that much time to go through as when there's 25 as when there's 25 million nodes. So, as you can see, this has huge implications. Like, if you tried doing this with Ethereum while it was like, you know, getting pounded with transactions, you would not be able to, that would have taken like a good couple of hours to go through. So, yeah, this was a demonstration of the pre-alpha Shardus consensus algorithm. And hope you all had fun.
Nice demo. Yeah. All right, so real quick, we're running a few minutes behind. So I'm sure you all liked the presentation that Omar gave about Shardus, and then on top of that, our first quarter achievement of completing the consensus algorithm. This is the dev team that you're seeing, that these are talented young kids who are building this. That means they have the interest, they have the passion for it, and they did deliver something that is usable as it stands right now. So obviously there's going to be more maturity that's going to happen over a period of time. But now let's talk, I'm going to bring another team member, Michael Mays. He's going to talk, he's going to let us know how and why we rebranded, and a little bit more about how you can help.
I just want to talk a little bit. I won't use the mic. I think you can all hear me. Just want to say this: if there's one thing that I'd really like you to take away today is that this group, we're not spending a lot of money on an ICO, and we're not spending a lot of money on marketing. We're trying to do this organically at this point. And so, if there's one thing you can take away from today is to please follow us. Follow this project, tell others about the project. If you have a Twitter account, follow us and retweet. If you don't have a Twitter account, get one. But mostly, just follow the project and watch our progress. And as we have more, you'll see, and there may be more things you can do. If you have some way you can contribute as a developer or anyone else, please let us know. You know, the one thing I wanted to talk about today, some of you may have been familiar with the project when it started as the Unblocked Ledger project. It's now changed to Shardus as a name. And really, it was to help us differentiate the technology from the new coin that will be created, the base coin. And also, Shardus in some ways may help us more for an international market. It's something more simpler, maybe something easier to define, and it's memorable. And the ULT tokens will be converted to Shardus tokens in the future. Liberdus, as we said, will be that first coin. That'll be the first coin that really the public is able to participate in. It's really a combination of libertas and solidus, which were ancient coins in Rome. And we think it's memorable and it's really aspirational, the liberation of money. And then you've heard us talk a little bit about bounty campaigns. Those are just campaigns that reward people for participating. They've been around a long time for bugs and software, of course. And so there may be many different things. If you are a writer, you could write articles that talk about the project, and you can also contribute as it develops. The social media bounty, you can go to our website where you'll see bounties, and you can go to a website and participate. Right now it's a test, but you can see how that will work. People, just for following us on Twitter or retweeting things, they'll be able to earn some tokens really quickly. That'll help us spread the word. You've seen today, of course, for Android, the one for Apple that's still kind of in production. And then I want to really open up the rest of the time for some questions, anything that you may have for the project and for Omar. Yes?
Are you guys going to announce that you're speaking at the Future of Blockchain Conference next Friday?
Ah, that's right.
Omar's.
Yeah, I'm actually talking at 2 other events coming up. Actually, before the Future of Blockchain Conference, which is in Frisco. I'm also talking at another session for the North Texas Blockchain Association. That talk is going to be a little bit more technical. It's about cryptography, and I'll be talking about the equihash algorithm that's being used in Zcash and how that works. And then at the Future Blockchain Conference, I'm actually going to be on a panel with people from either Hashgraph and Ethereum and Cordova, and we're going to be kind of talking about the different projects and how they compare and so forth. I'm also going to be doing a separate talk, just going into like some of the aspects of the features that are going to be in Shardus. So if you can make it to those events, that would be really great. Any other questions?
Yeah, you explained that genetic drift consensus. So it is like scalable because of the genetic drift, your Shardus that you're building.
Yeah. So the scaling. So the question was, how does the genetic drift algorithm scale? So the genetic drift algorithm is really more for doing the consensus efficiently. The scaling part of it comes when you do that, consensus in lots of different shards. And so the scaling part of it has to do with how many shards that you have, and each shard will be running that same efficient consensus algorithm. So the genetic drift is really to make the consensus be more efficient, but the sharding part is going to come, or the scaling part is going to come from the sharding aspect.